Now, the next thing to talk about will be the linear dependency. So, a system of in a system of vectors or list of vectors, we're trying to check if the vectors is linearly dependent or not. So, what linear dependency is saying is there a vector in this vector that can be represented by the other vectors? Maybe something like v1 equals to v2 plus 5, let's say 2 v2 plus 3 v3. So this system may consist of v1, v2, and then v3. Or let's say v1 equals to 2v2. So if there is anything like this in our system, then one of the vectors is depending on another. Do you understand? So if there is any depending, then we said our system is linearly dependent, and if there is none, we said our system is linearly independent. So how do we test for it? So let's say for v1, v2, v3, these are our vectors in a vector space V. There exist scalars a, b, c, where see this formula: a times v1 plus b times v2 plus c times v3 equals 0. So a times v1 plus b times v2 plus c times v3 equals to 0, where a, b, and c okay, let's use our zeros. So if you are given a system of vectors, a list of vectors, and they asked you to test if they are linearly dependent or not, you bring in some scalars, your a, b, c, then you multiply it and form a formula like this. So after solving the formula, if a, b, and c are all zeros, then your system is linearly independent. It is linearly independent. See the trick. When they are all zeros, it is linearly independent. But when they are not all zeros, if you cannot assign 0 to all your scalars that you bring, then it is linearly dependent. So there is a dependency in your system. So now let's kind of solve a problem. They said number one, okay, u equals to 110. You see, and then v equals to 132. So these are all our vectors. Then w equals to 495. So now they say we should solve this equation. First, you write your formula out. So we need three scalars. So we can now say a times u plus b times v plus c times w equals to 0. After solving this solution, or this equation, sorry, a, b, c must all be equals to 0. If they are equals to 0, so this list of vectors are independent. But if we cannot assign 0 to all our scalars, then it is dependent. So now let's do that. So one thing you do is Now you can now say A times 1, 1, 0. Then close this. One, 1, 0. Then close this. So now let's do it at A times this. You are just going to use the bracket for this in your notes. You don't need all this unnecessary space. A board will be better, but I don't have that now, so that's why I'm using this. So the next thing to do, oh shit, this doesn't look nice at all. And I want to represent it the way it will look in the notes. So that's how we should write it in the notes. But so this is A times plus V times 1, 3, 2 plus, so this is B, then plus C times 4, 9, 5. Now let's try the equation out. So it should be equals to what? If you remember, it said it should be equals to 0. So now we cannot just do 0, 0, 0. Now we can now write our equation. First, we times A by the first number in that first equation. Then we times B by the first number in the first equation. Then we times C by the first number in the third equation. So sorry, third vector. So it will now be 4C equals to 0. That will be the first equation. Then we also have A plus 3B plus 9C equals to 0 in the second equation. Then it will now be 0, or don't just leave it that way. 0 plus 1B plus 0 plus 2B plus 5C equals 0. So can you see it, guys? So this is it, this and this. Now all we just need to do is, you should eliminate this system. You're trying to get A, B, C value. So you can use the elimination method, and that's what we are going to use. First, you rewrite this A plus B plus 4C equals to 0. Now we should eliminate the second row. Let's eliminate A from this second row. So by just subtracting the first row from the second row, so this is the first row, right? So we can now do 2 minus 1, that is this row minus this first row. So A minus A will give us 0. 3B minus B will give us what? 2B plus, okay, 9C minus 4C will give us 5C equals to 0, right? So we have our equation here. Now the third one is already reduced, so we don't need to just leave it that way, plus 5C because equals to 0. Now what do you do next? Write the first one the same way. A plus B plus 4C equals 0. Rewrite this 2B plus 5C equals 0. Now what do you need to do? We should eliminate the next one. By eliminating B here, we will also eliminate C. And what we get is 0 equals to 0. So this system, we do not solve it. We can't find any solution to it. We do not get A equals to 0, B equals to 0, C equals to 0. We get 0 equals to 0. That means there are many solutions to this system. So it is linearly dependent. So it is dependent. With our rule here is A, B, C must be equals to 0. And with this system, A, B, C are not equals to 0. We cannot assign value to them. We get 0 equals to 0 and a free variable in our system. So just know when you get 0 equals to 0 or anything that is not A equals to 0, B equals to 0, C equals to 0, then we say this system are the vectors are linearly dependent. So that's our conclusion. So now let's do another solution. So I'll try and get a question real quick. So number two, this is our vectors, right? You can see all the vectors here. So we are to test if this system is linearly dependent or not. So the first thing we do is introduce our vectors, and you can just do this. A times v1 plus b times v2 plus c times v3 must be equals to what? Must be equals to 0. Now you can now rewrite as a times 1, 2, 3 plus b times 0, 1, 4 plus c times 2 minus 1 minus 1 equals to 0, 0, 0, 0. You can just write 0 here or 0, 0, 0. Now, we should rewrite this and form our three equations. We should be able to form three equations here. It will now be a times 1, a plus 0 times b is 0. Then the next one is 2c equals to 0. Then the next one will now be 2a plus 1 times b, b minus c, because c times minus 1 is minus c, so equals to 0. And the third one is 4a plus 4b minus c again equals to. So now we need to eliminate a from this equation. So we want to eliminate a. Now, what do? We multiply the first one by 2. So 2 times this equation and we'll be able to eliminate a. So 2b will now be minus 2a. So, or you can just do it from the top. So 2a here minus 2a here, sorry, 2a. 2 times this equation will give us something like 2a minus or plus 0b plus 4c. So that's what we get. So now 2a minus 2a. First, in this next one, write out your current equation. Write the first one. Then the second one you eliminate. 2 minus 2a will be equals to 0. Then 0b minus b will be equals to what? Minus b or minus 1b. Then we have 4c here. 4c minus c. 4c minus c. Is that not plus? That will be 5c. So I'm coming. I want to use. I'm coming. So we have 4 minus 1. So yeah, correct. 5c. So here will be minus b plus 5c equals to what? Equals to 0. So that's the next one. Now, the next one here, we want to eliminate a. So we need to times this equation by what? By 4. So it will now turn to 4a, then this will be 8c. So 4 minus 4 will give us 0, so we eliminate the a. So this will be 4b, so it will now be minus 4b. Then the next one, 8c minus minus c will now be plus 9c, which is equals to what? Equals to 0. Now we are done with that. We are done with that equation, right? The next one, write this out. A plus 2c equals to 0. Or if you want the b to be there, you can still put it this way. Then the next one will now be minus b plus 5c equals to 0. Then the next one, we need to eliminate b. So if we times this by 4, so minus 4 minus minus 4, you see 0. So times this by 4, then minus this one from it. So this will turn to minus 4b plus 20c, right? So we have 0, then 20c minus 9c, which is what? 20 minus 9 will be 11c equals to 0. So from this, we'll be able to get our c. So this system is solvable. You see, we are able to get our value c, and there is no free variable here. All of this, there's a here, we have b to b, and here we have a, b, c. So no free variable. Now we will explain what free variable are in the next soon. Now let's solve for our c. 11c equals to 0. What we are just saying is c equals to 0 divided by 11, which is just equals to 0. So 0. So here we say c equals to 0. Put it that way. Now let's take an equation here and bring it. So minus b plus 5c equals to what? Equals to 0, right? By bringing b to the next part equals to 0, let's just bring b here and we now say 5c equals to b. You see, right? Or we just say b equals to 5c. And then what's our c? Our c is equals to 0. So b equals to 5 times 0. So our b is what? Our b is equals to 0. So we get that. Our b is equals to 0. We need to get our a. So a plus 0b plus 2c equals to 0. Now just plug in all our values. A plus 0 times 0, 0 times 0 plus, plus 2 times 0 equals to 0. Is that correct? So a also equals to 0. And then from our first rule, a, b, c, that is all our scalars that we introduce to the equation must be equals to 0. Then when they are equals to 0, we have a linearly independent system. So here we are able to solve c equals to 0, b equals to 0, a equals to 0. So this list, or yes, this list of vectors are all independent. They are independent. So yeah. So that's how we solve for linear dependency. So when you are given list of vectors, introduce scalars, and you need the number of vectors. You need the number of vectors. I mean, when you are given 4 vectors, you need 4 scalars. 5 vectors, you need 5 scalars. So introduce the scalars, multiply each scalar by 1 vector each, and equate the equation to 0. Form a list of equations, then you eliminate. So this we are doing here is just eliminating to find a, b, c. So when you find a, b, c and they are all equals to 0, then it is linearly independent. linearly independent. So when you are solving for linearly independent, if they are not equals to zero, then you will get some value that when you get zero equals to zero, then you have many solutions. So they are linearly dependent. So when you get zero equals to zero, linearly dependent. When you get A equals to zero, B equals to zero, C equals to zero, they are linearly independent. So now the next thing to do is by, the next thing, okay, let's just round this up. So this is how to test for linearly dependency and independence. So we learn about vector space, and then we learn about how to test for linear dependency of vectors.